Hello everyone. Let's go through the medium LeetCode problem of finding the longest substring without repeating characters in Java. While going through it, I will try my best to explain the thought process, so this may help you in your future tasks. Let's read the description. Given a string s, find the length of the longest substring without duplicate characters. A substring is a contiguous, non-empty sequence of characters within a string. And we are given a few examples. Let's take one of the examples and really look at it. I think example 3 would be great, as it also has a clarification that we need to understand. It says, notice that the answer must be a substring. PWKE is a subsequence and not a substring. All this seems to tell us is that we need to use a continuous part of the given string without repeating characters. If we meet a repeated character, then we need to only account for characters after the duplicate. Firstly, what's good for us is there doesn't seem to be any other effective way than to simply start from the beginning of the string and go through it, left to right. We go character by character and check if we met this character before. If we do, we make necessary calculations and go on. Also remember that positions in Java strings start with 0, as we need to work with those positions during the task. Now the question is, what is the best way to make those calculations and determine the answer? My first idea is to go character after character, but also store its location. That way, once I meet a duplicate, I will know exactly where it occurred. For that solution, I will need a map, where the key is a character of the given string and the value is its position. That way we always keep necessary data about our not repeated substring. If the next character of the given string is not in our map, we simply put it inside. But if it is, then I need to reorganize my map and continue. As you can see, I have my map and I also have a counter to store the length of the biggest substring. I then go character by character, and if I see that my map doesn't have it as the key, then I add it with its position. Its position is stored in the for loop as the I variable. If my map does have the current character, then I check if my substring is bigger than the found maximum length, and I start moving through the word again, but moving just after the found duplicate. Notice that I value will automatically move after the duplicate because of how for loop works. In this solution, I also have to empty my map, because I went back in the given string and I will encounter some characters again. Let's check the results. As you can see, my cases pass, but the speed is pretty bad, as it is bigger than 90 milliseconds. The obvious reason is that after I find my duplication, I empty the entire map and go through the letters that were already checked. How can we avoid redoing that work? Instead of emptying the map, I could simply remove the letters before duplication. Then I don't need to go back in the given string. So how can I do it? I know the location of the duplicate character, so I need to remove all positions in my map that are smaller than the found position. I iterate through the map, find every key, the value of which is smaller than the duplicate position, and then remove every one of those keys. After you saw my changes, let's check the results. The speed is noticeably better, but it's still far from ideal, bigger than 40 milliseconds. That's also understandable. Each time I find a duplicate, I have to delete all letters that have positions before the duplicate. That means going through the whole map, checking all values. The bigger the map is, the longer it is going to take. There is a much better solution. It's an algorithm that is useful in many cases. It is called the sliding window technique. In fact, if you never used it, the current task is a very good introduction to this technique. Well, how exactly does it work and why is it a good idea to understand it? As the name suggests, we use a window. Our window is a subarray of elements that is part of the given array, and we do our calculation with the help of this subarray. It helps us avoid all the rechecks, because the current data inside the window is known, and we only update it if we need to. Basically, it is an effective pocket of data that we can fastly work with. In the context of this task, our window is the current substring without duplicates. We add elements by going through the string from left to right. If we find a duplicate, we change our window by sliding it, meaning by removing elements from the left that can no longer be a part of the window. If we find a duplicate, we also check the size of the window to find the biggest found size. This technique is very good if you need to find a subarray with the required condition optimally. Let's check this solution's code. As you can see, our window is defined by its left and right borders. The current string stores only non-repeated characters. The right variable also helps us iterate through the word's characters, because whether we find a duplicate or not, our window would still have to keep moving to the right. If we don't find a duplicate, then we simply increase the current string. But if we do, then we need to check if we found the new biggest substring. The two tricky lines of code are here. To understand it, let's look at another given string. Imagine that we are at a point where we encounter the second b in this string. Our current string is bca. Our left variable, which points at the first b of the given string, must be updated properly. It should move further to the right from the previous position. To do that, we take its current value and add position of the duplicate in the current string bca. That's because current left value already excludes all the previously checked characters, and current string contains the part of the given string that we are currently checking. So we have all we need to move further in our given string. +1 is there because we need to move just after the duplicate. The other line of code is there to update the current string of not repeated characters. You might ask why we add 1 to the right. That's because of how the substring method works. For example, method char@0 returns the same value that substring 0 to 1 does. That's why we need to add 1 to the right variable when redefining the current string. As you can see, I put my solution into LeetCode. Let's check the results. Now it is much better. It went from 90 milliseconds to 40, and now it's 8. If you have any questions, feel free to ask them in the comments. And if you enjoyed the video, please like and subscribe. It really helps the channel grow and lets me keep making more content like this. Thanks for watching.